Introduction. As I am an avid D&D player, I am interested in the physics of dice rolling. I wish to understand the mechanisms behind if a dice rolls or does not based upon the height dropped and therefore transfer of angular momentum from my hand multiplied by the time spent accelerating due to gravity. Since hands are not perfectly still when they drop dice, they transfer some kinetic rotational energy, and if the center of mass of the dice tips more than half of its longest diagonal, it will begin to rotate, which is also a function of how much it rebounds in the material used in question. Physics principles. The potential energy of the dice in question is measured by mass gravity times h, where h is the distance above the floor in increments of 10 inches, 5 inches, 2 inches, 1 inch, and a half inch converted to centimeters, which is thus converted to kinetic energy. The accelerative rate that a chosen edge of the dice begins to rotate from a different perspective before it hits the ground is partially indicative of the transferred kinetic energy from hands, as gravity simultaneously acts upon it. Rotational speed can be calculated by 2 pi over t, where t is the time it takes to make a full revolution, and the rebound rate is calculated by how far the dice jumps back upwards after it falls. Hardwood floor, like that used in the experiment, typically has a rebound rate of 30%. Dice dropped from 10 inch, 2 inch, and 5 inch tend to rotate consistently, while dice dropped from 1 inch or lower roll inconsistently if they do at all. The system is primarily the dice itself as it falls and hits the ground, which may cause it to rebound with enough rotational momentum to start spinning, overcoming inertia. The initial conditions are those of the different heights at which the dice was dropped. I analyzed several of the videos taken from Tracker to ascertain relations. When the rotational speed of the dice is maximum after initial collision, it rotates at approximately 1 time per frame, 30 frames per second. As each rotation covers an area of 3.2 centimeters, that would be an angular velocity at about 1 meters per second at peak, which does not last long due to friction and conflicting torque from hitting the ground multiple times at different angles, which eventually cancel out, as demonstrated additionally in the generated tracker graphs. What is lost to heat is due to dispersion forces. Additionally, angular velocity/speed can be estimated based off the equivalency between velocity and the radius of the object, with max velocity about 1 meters per second, resulting in an astonishingly high angular velocity. Dice grow significantly more likely to roll the higher up they are dropped, and roll more dramatically when they do, due to the increase in rebounded kinetic energy and angular momentum generated thereof, which should be modeled given initial angular momentum from the hand, alluded to from the behavior of falling dice and the angle at which it collides with the ground of known physical properties.